Hello everyone, in this video I'll be explaining you the problem magic squares in grid. So let's read out the problem. So a 3 into 3 magic square is a 3 cross 3 grid filled with the distinct number from 1 to 9 such that each row, column and both diagonals all have the same sum. Okay, given a row into column grid of integers, how many 3 cross 3 magic square subgrids are there? Note, while a magic square can only contain number from 1 to 9, grid may contain number up to 10 power 15. Sorry, not 10 power 15, just 15. So yeah, let's take this example and let me go to the board and tell you like what they're trying to say. So we have a 4384, right? Then what do we have? 59519. Then we have 2762. Okay. So yeah, let's see. So in the problem statement, what they have said is uh, a 3 cross 3 magic square. Why 3 cross 3 is a square? Because if you see 3 cross 3 kind of look like square because it has 3 columns and 3 rows, right? And it look like square. So it is a magic square in which all the elements are unique. Like if you try to insert elements, unique elements, how many elements you can insert? 7, 8, 9. So 9 elements you can insert. So that's what they're saying. In the magic square, number should be from 1 to 9. Okay. And the sum of each row, if you take this is row 1 sum, this has row 2 sum, this has row 3 sum, okay, and this has column 1 sum, this is column 2, this is column 3, this is diagonal sum, this is other diagonal. So all the sums are equal. Okay, all the sums are equal if it hold these conditions, like the numbers are unique from 1 to 9 and all the rows, columns and diagonal, both the diagonals have equal sum, so it is said to be a magic square. So we have given a row cross column grid of size wherein row has row and column is column. So we have this size grid. In this we need to find how many magic squares are there. Okay, so as you can see, this is a grid. Okay, we can consider this as a grid. So if we see how many rows are there, 3. So it's a 3 cross how many columns? 1 2 3 4 4. So here row is 3, column is 4. So we have 4 cross 3 matrix, and we need to find the 3 cross 3 square magic square. So if you take this square, okay, so let me write it here one more time: 438 951 276. So if you look into this, we have 1, we have 2, 3, 4, 5, 6, 7, 8, 9. So all the elements are unique. We have 9 elements. Let's try to find the sum of this row. So 12 plus 3 15. Okay, this if you see 10 plus 5 15. This if you want to see 9 plus 6 is 15. Column sum if you want to see 13 plus 2 is 15. This column 8 plus 7 is 15. This 9 plus 6 is 15. Now if you want to see diagonal, this diagonal, so it is 9 plus 6 is 15, and if you want to see this diagonal, 7 plus 8 is again 15. So if you see all row sum and column sum, diagonal, both diagonals all are equal. So this is a valid magic square. So your answer now is 1. Now do you have one more magic square? We have. If you take this one is also magic square, right? We have 3 cross 3 matrix. So let me draw it here. we have 3, 8, 4, 5, 1, 9, 7, 6, 2 we have, right? So now try to see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So all elements are unique. Fine. Let's try to find the row sum. Okay. 12 plus 3 is 15. 9, 10, 15. And last row sum is 8 plus 7 is 15. Okay. Now if you see 7 plus I 12 plus this 3 is 15. 9 plus 6 is 15. 9 plus 2 is 11 plus this is 15. Now if you want to see diagonal, it is 8 plus 4 is 12. Okay, so you have seen difference. Now let's try to say this one. It is 3 plus 4 plus 2 is 6. So if you see, we have 15 as a row sums and columns, but diagonals are not equal. I mean this all value has to be same. If you see, it is all 15, but here we have 15, 12, then 15, 6. So it is not a magic square. So in this case we have only one magic square. And if you want to see other 3 cross 3 matrix, you can't do it. So always in this example we have only 2 matrix, 3 cross 3 matrix, right? So I think this problem is simulation problem. So I'll be writing the algorithm how to solve this. And since the size of the constraints are also very less, so we can easily write the simulation problem solution, directly implement it. So if you try to see the row size, row and column size at max 10 as the size, okay, and grid has value 10 power 15. So at max like row size will be 10 and column size also at max will be 10, not more than that. So even if you solve n cross n algorithm, so it is going to be 10 power 2, which is going to accept. So okay, so what we are trying to do is first let me write the algorithm. First we'll try to make sure how many 3 cross 3 matrix are there. That can be done using 2 for loops, and I'll start I from 2 to n minus 1. Why 2? Because see, I'll be moving, this is 0, this is first, this is second. So okay, so I'll be taking from this row, because from this row I'll be moving 2 steps back in order to find 3 cross 3. We have this one row, second row, third row, so that's why. In the same way, column also I'll be taking from 2 to m minus 1. So this will be m. I'm taking row as m. I'm taking row as m and column as n, and this is going to be n minus 1. I'm starting from 2. Why? Because 0th first, second. So from here, like my first position will be here, and from here, if you want to see 3 cross 3 matrix, go 2 step back and then 2 step back. So this entire thing will be your 9. Now when you're moving forward, so again move 2 step back and move 2 step back. So from here this will be 3 cross 3. That's why I'm doing that. So when you're now these 2 for loops are clear. Now what we need to do is we need to check the elements whatever is there in this are all having unique values, and it is within the bound from 1 to 9, right? So we need to check uniqueness and bound. Bound is like from 1 to n we have values or not. If you don't have any values is surpassing 1 it is not in the range from 1 to 9, so you need to just return false, so it will not be a magic square according to the definition. And if you find that the elements in this are double, it's not unique, so you can again return back. So once uniqueness and bound is checked, this I'll be telling you in the code how to implement the logic. Uniqueness can be done using a set, because in the set will be insert all the 9 values. If set size is 9, then it is all having unique values, else it is not. So yeah, and bound value directly we can check from 1 to 9. So we'll write a function and we'll check it. So once we are done with this, now next we need to find the row sums. Okay, row 1 sum, row 2 sum, row 3 sum we'll be finding, and these sums will be inserting into one set data structure. Okay, Why I'll be inserting it to set data set here? Because all the sums has to be unique, right? So if the set has multiple values, which means the sums are not unique, right? So if set has only one value, which means all the sum values are unique. So in that case, our we have found like one magic square. So I'll be finding row sums. Okay, row 1 sum in the same way row 2 sum, row 3 sum. Okay, and all the values separately I'll be putting into set. In the same way, I'll be finding column 1 sum, column 2 sum, column 3 sum. Okay, and then I'll be finding diagonal 1 sum, diagonal 1 sum, and diagonal 2 sum, because one diagonal is this, other diagonal is this. So diagonal 2 sum, and all these values I'll be putting into set. If set has one value, which means its size is 1, which means all the row sum, column sum, diagonal sums are having unique value. So in that case, I'll take one variable answer. Initially it is 0, so I'll be increasing that answer. So I think we can go to the coding part, and let's see. Coding part is lengthy a bit, so yeah, we'll have to manage a bit. So I've already written the code. So let's try to write in front of you one more time. First thing first, I'll take m as the row size, n as the column size. Okay, and as I said, I'll take one variable answer, or we can say magic squares. Okay, it is initially 0. As I said, I'll run a loop from 2 till m, and I'll run a loop from j, again same 2 till n, j plus plus. Now first thing first, what I said is you need to check the uniqueness. Check bound and uniqueness. So I'll name the function as check bound and unique. What I'll pass is I'll pass I, j, and then I'll pass this grid. If uniqueness, this function return false, which means there is a chance that either the whatever value in this 3x3 matrix we have, it is not in the bound, or it is not having a unique value. So in that case, we need to continue in the sense we'll have to move to the next iteration. We should not be doing other things. Okay, let me write this function. It is a boolean type. Okay, we have I int j. Okay, and this vector we are passing. So now we need to find, I'll take one unordered set. Okay, now I'll run a loop. Let me call it as a row, and this will run from I minus 2, because I'm starting from 2, so I should go move 2 step backs. As you can see here, it's like I'm starting from this position, you should move 2 step back, and here also you should move 2 step back. Your row is less than equals to I. So if you are moving 2 step back, like row, you are here 1 2, so this row you will be checking, then this row will be checking, then this row will be checking, so it is equals to I. Okay, then row plus plus. Similarly, we'll go for column from j minus 2, column less than equals to j, column plus plus. Now it's a for loop. Now first thing first, we need to check if this grid of row comma column, whatever value is there, if it is less than 1, or this value is greater than 9, so it is not in the bound. Okay, so if it's not in the bound, we need to return false. So whenever it returns false, so it will be equals to false, so we are going to the next condition, right? So it's like we have found the duplicate values. Not duplicate, sorry. It's like we have found the uh, out of bound value. Okay. If it is within the bound, so we need to insert this value into set. Why? Because all the 9 values I'll be inserting into the set, and later I'll be returning if the set size is equals to 9 or not. If it is equal to 9, which means it will return true, so all the 9 values are unique and within the bound. Okay. If it is not, then it will again return false, and yeah, we'll continue to the next iteration. So if it returns true, it means we have all 9 elements as unique and it is within the bound, like from 1 to 9. So we need to get the row sums. Okay. So before that, I'll be taking one more unordered set. Okay. Now I'll take row 1 sum. I'll name it as I'll name the function as get row sum. Okay. So it's like when I'm here, I want the row sum first this, then this, then this. So my I, whatever I have, I'll be passing -2. J is same only. J I'll pass in -2. It's like, see, I'm at this position initially, so I should be moving from this. I should find this sum, then this sum, then this sum. Okay, and I'll pass grid. Now row 2 sum will be uh, I want row 2 sum, this sum. So my I is here, so I should be moving one step back just. So it is I -1. Okay, and I should move 2 step back as j, because I'll be starting from the 2 step back. And row 3 sum is going to be the same I. So it's like I'm starting from my I is here, I should start from same I only, but j has to move 2 step back. So let's write row sum. So I'm passing I, I'm passing j, and I'm passing this vector. Okay, so whatever row is there, it's like only 3 values, right? So what I'll do is I'll take one count. First I'll take sum, initially it is 0. I'll take count as 0. I'll take a loop while count is less than 3. So it's like only 3 times this will be running. So I'll take the value from grid I and j. Okay, so when you're taking the row sum, so your row remains same but your column moves forward, right? So I'll make sure your j is increasing, right? And when my sum is there, so I'll return sum. I think this you have understood. So I'm taking care of this position, I and j positions where I should put. So it will return the row sum, and the row sum's value will be like only 3 values. Okay, which is taken care by count. So I should make sure count I'll have to increase. Okay, and whatever rows I'm getting, I just need to insert into my set. Similarly, I should do it for row 2 sum and row 3 sum, right? Okay, now I'll try to get the column sums. Okay, what I'll do the same thing, int column 1 sum, which is going to be get column sum. And if you want the column sum, just like you should be you want this one 4 9 and then 2, like this, right? So what you'll be doing is I you will be passing as -2 because it should move up, and then j also -2 will be passing, and then grid will be passing. Now let's see what will be the column 2 sum. Column 2 sum is you want this sum. So again I will be 2 times back but j will be 1 time back. So I is 2 times back but your j will be 1 time back. Now if you want column 3 sum, so it's like you are here, so this column sum you want, so I will be as it is, so you should not be changing, but j will be 2 step back. Okay, now let's define this function. So I'm passing grid. These things will be again same. Okay, now we should not be increasing j. So when you're taking the column sum, so column remains same, but I keeps on increasing, right? We should be increasing column. Okay, so this gives column sum and we need to insert the column sums. It will be column 1 sum, this is column 2 sum, this is column 3 sum. So we have inserted into set. Now we need diagonal sum. We should get diagonal sums. Okay, I'll call diagonal 1 sum get diagonal sum. So first thing first, I want diagonal in this way, this diagonal. So my I is here, I'll be moving 2 step backs, both I and j, because if you move 2 step back as I and 2 step back as j, you'll be reaching here. So I'll be passing I minus 2, j minus 2, and then grid. Similarly, I want diagonal 2 sum. When I want diagonal, let me call get diagonal sum 1, get diagonal sum 2. So I'll be writing a separate function while I'll be telling you. So diagonal 2 sum means I want this sum, right? So my j is here, but I will be moving 2 step back. So let me write this function diagonal 1 sum. The reason I'm writing function is that our code will be more readable, that's why. Okay, so first thing first, I want diagonal 1 sum. Diagonal 1 sum means I want this sum, these three. Okay, these three means my I is here, so what I'll do is I'll take sum initial as 0, same count will be 0, and while my count is less than 3, what I'll do is I'll make sure sum plus equals to grid of I j, but you have taken this sum, you should move next step ahead. If you want to move ahead, so I you will move forward and then j also will move forward. Okay, I is moving forward and then j also is moving forward. So similarly, when you are here, so I should move forward, j should move forward, so you will get all these three. And when count is less than 3, equals to 3, it will come out of the loop. You need to return sum. Similarly, we should be writing diagonal 2 sum. So it is diagonal 2 sum. So we have already passed I minus 2 and j, it is here, so I should want this way. So see, I'm taken the sum as I comma j. I should move forward. If I want to move forward, I should be increasing by 1, j should be decreasing by 1. Okay, when I'm here, I should increase move 1 step ahead, and then they should get back 1 step. Okay, so it's like I plus plus j minus minus. So we have got the diagonal sum also. So it's like we have got row sum, we have got column sum, we have got diagonal sum. So these diagonal sum I'll be inserting into my set. So diagonal 2 sum. Now for last thing we need to check is if this st dot size equals to 1, which means all the sums are unique, like all the sums are same only. So in that case, your magic square is going to increase by 1. Okay, else here it is not a magic square. So at the end we'll have to return the magic square. Now let's try to run it. It is getting passed. Let's try to submit it. So yeah, it got accepted. So in this way you can easily solve the problem. This problem is more of simulation. So Yeah, and then the coding, if you see, it looks very clean. So I think you should write in this only codes so that it looks real and readable. So if you want to go to any uh, whatever you want to check, whatever you're checking, so you should be writing in a function. So yeah, like it's written very clean. So yeah, thank you guys for watching the video.